The problem I decided to do is the max grating spacing problem. So this problem says a laser emitting light of wavelength 582 nanometers is incident on a diffraction grating. What is the maximum number of lines per centimeter for which m equals 3 principal maximum will be visible? So here we can start with what is diffraction grating. Diffraction grating is a series of many narrow lines or slits on a flat surface. So we are given m equals 3. So what this means is that there is going to be 3 light waves going through our diffraction grating. So we can look at these light waves as, for example, here is our diffraction grating there. And then we have the wavelengths. So we're looking for the principal maximum. So when they say principal maximum, it means we're looking for this point, that m equals 3. This is, well, right here, this is m equals 0, m equals 1, m equals 2, and then over here is m equals 3. But these points are our principal maximum. So when going about this problem, we need the max grating formula, which we can use d sine theta equals m wavelength. So we already know our wavelength, which is 582 nanometers. But we're trying to find d in order to put it in our formula d equals 1 over n, where n represents our lines per centimeter. Lines. So since we're trying to find d, we can use sine of 90 so that all our waves are in phase, equals 3 wavelength. So with this, we end up, sine 90 goes to 1. So we get d equals 3 times the wavelength. And with this formula, we have 3 wavelength equals 1 over n. And if you do a little bit of algebra, you end up getting n equals 1 over 3 times the wavelength. So now we just plug in what we are given to find our n, which is the lines per centimeter. But in order to do this, we need 1 over 3 times the wavelength, which is 582 nanometers. But we need to convert this to centimeters, so we get lines per centimeters. So we multiply this by 10 to the negative 7. And this ends up giving us, well, approximately 5,727 lines per centimeter. So one way we can check this solution is to take our n here and plug it back into the original formula and try and solve for m, or our wavelength. So what we can do is we know d is equal to 3 times our wavelength. So 3 times 582. And then we can do sine of 90, which goes to 1, divide it by 3 equals wavelength. And if you put this into a calculator and solve, you get 582 is equal to 582. So therefore we have checked our answer.